Hi design thinkers, today we'll be going into the advanced theory behind atomic design systems and system thinking. And I would advise check out this video if you're interested in understand the complexities of building out advanced design systems. Because throughout the other sequence of videos, I will be going over the key points addressed in this one. So, if you're interested in skilling up and growing as a designer, then sit back, relax, and let's jump into the video. All right, here we are, designers. We are inside of Figma. We're going to be getting into advanced design systems. We're going to be covering our atomic design, a slight adjustment to atomic design using my Quarks concept framework. And then I'm going to be talking a little bit about systems thinking. All in all, this is all to help us design amazing products for our customers and to design systems that support us and support our teams in the process of doing that. So let's start with a couple of basics and then we'll go from there. I'm going to cover atomic design from Brad Frost's Atomic Design Principles and changing this a little bit. But let's understand a couple of basics if you have not heard of atomic design before. Atomic design is where we're creating UI design systems and we are building the atoms, which are the basic elements of our design system. That is like our buttons, that is like our input fields, that is like our labels. Then we are putting buttons, labels, and input fields and elements like that together to make a molecule. The molecule basically can obviously change and be reused, but it is a collection of those elements. When you put enough of those elements together and they serve some sort of purpose, they become a type of organism. And that organism can then be used in various different ways on structures. Like our templates structure out how we can use our organisms, very much like a website, and the way that the website works has variations of structures that have different types of organisms on it. And then finally, we have our final design, and that is basically our final designed website page for our client that is unique and specific to them, which is great. From this framework, I will break this down a little bit more. I'm going to start to incorporate new design practices like using design tokens throughout our design system. And then I'm also going to get into concepts around interactivity, adaptability, and the use of data and information in our design system as well. And before I jump into that, I'll just demonstrate this. In the end, we're building interactive experiences for our users. We can come up with fantastic concepts and work with our users to understand their needs. We can use these concepts, we can use the pieces that they will interact with and that we can understand them. Everything on this screen is all interactive in the end. These change, develop, grow, and adapt over time, just like our products do. And so does our design system need this capacity. It needs to be able to change and grow over time. Currently, our design systems are mostly UI-led and not able to support the complexities of interactions and the complexities of the changing environment. So let's start thinking about how we can get there. Let's start breaking apart the atomic design principles and understanding how we manage our design systems and how we construct our design systems to incorporate more flexibility, more modular approaches to building these designed structures. This is where I come into the concept of the Quarks framework. I've taken and added and expanded upon Brad Frost's work. Amazing work. If you haven't checked it out, I 100% suggest going through his material, getting familiar with it. But let's start thinking about how we can use what I'm terming as quarks, the fundamental blocks of our design system. These are our design tokens. They are the borders that we use. And as borders change, as we are using different hover states and different primary, secondary, tertiary states of our buttons or our input fields or our other designed elements, these are different states of what a quark could be. But they're all borders, and they're all borders, and they all change, and they all use particular sequences of colors and shading and different tonal values. Understanding how these fundamental pieces talk and communicate the styling beneath the component allows you the ability to be more flexible. When we build out what I'm saying is the tokens, the Quark framework, we need to build them out so that they're modular and they're flexible and they can change. So start using inside of Figma today your design tokens. You can also explore using the actual design token plugin to also expand upon the use of the ways you use fonts to borders to styling to components, and then start to really get granular so that you have the flexibility to change and adapt your design elements and components quickly and easily than ever before. When you have adaptive and responsive changing components, now you can start to think about pieces when you put them together and you build, for example, your buttons, your input fields, your other interactive elements. Anything you make now has the level of granular control underneath the designed element, giving you ultimate control of creating a million different styles of one thing. I could make one button, and making one button, I could make 100 different buttons that will do different things, serve different purposes for different products in my complete ecosystem. They can adapt, they can change, and they can respond to the needs of the user. And that can be you as the designer, but it also can be the needs of your developers, the needs of your product managers, and the needs of your end customers or users. Building the atomic actual atom, then you can incorporate other elements inside your atomic atoms. You have sound, you have your movies, your animations, transitions, you have different behavioral elements you can control for inside of this. So I really encourage all designers to start growing what you can do with these atoms. Having a button with sounds included into it that pull from a collection of your sounds from a sound library will grow your design to make it the next level of what a design system can have. From that, we can put these pieces together. They're interactive, they change, they adapt. They have the fundamental blocks behind it that allow you the capacity to make and change and grow. So every level up from your base structures start to create more and more dynamic, more malleable, more adaptable actual components. And this is the molecule. Imagine a search field. Imagine a search field where we have your input, you have your search button. But imagine a search field now that, because we put all those bits and pieces behind the hood, we can instantly change all the uses of colors, all the uses of every element's way of changing states. And we can do that through the fundamental quarks that we've put together. And then from the buttons that we have and the search fields that we have with the interactions, we have access to more pieces of the framework. We can add in more sounds. We can add in different interactions. Like, for example, a search field could potentially have predictive text. And having predictive text, I could have part of search fields a corresponding component that will allow and animate and demonstrate predictive text in my design system. This will allow us to communicate to developers and product managers and various other stakeholders the actual interactive nature of it by demonstrating predictive text. So, as we evolve our design systems, we understand that our molecules can have a lot more in there than just the UI elements, but also the interactivity and the animations and the sounds and other pieces that communicate the human experience. As we build all these pieces and we put them all together, those molecules are all just bits and bobs. But when you put them in together, you build something like matter. The matter is like water. Water can boil. Water can then turn into steam. Water can then come down as rain. And then as it comes down as rain, it cools. And if it cools too much, it can eventually freeze. Matter changes states. And like our components in our design system, they change states. If I am doing a particular thing, let's say we have a user application with different admin privileges, then we need to understand those different states. We need to understand as things and design elements and design components are used through different states, they present themselves differently to different users. Not just different users and understanding those different states, there are multiple other actual use cases for understanding and building design elements that have the states to change into different things. That could be as simple as having hover states, focus states, as well as disabled states, approved states, declined states. These are all the states of what your component could have. But we can expand upon that and deliver it through our matter components. Eventually, we have all the matter components that we could ever desire. They can change, they can adapt, they can respond to users, they have comings and goings of information, and this is where we have our organism. Eventually, when we're designing, we could consider it like designing a screen. We could consider it like designing a complete product. It could be a complete sequence of events that take place through a user flow. That could be your organism. The organism is an experience. It is a complete part of the product, or it is the complete product. But the organism can learn, grow, and adapt. You need to build and design these organisms that have the flexibility to respond to inputs and outputs, respond to user data, that can leverage every layer of the actual quirk addition framework from bottom up. When I change a quirk, I can change that token. That token can populate up the chain. It can change the matter, and then the matter could eventually change the whole experience, which can change this whole organism. from changing the colors to then changing the interactions to then changing the inputs to changing the complete way that you can communicate. You have the granularity that you need to grow and build a design system that is completely responsive and adaptive. So as we're building those complete responsive and adaptive design elements, we need a way to think about it. We need a way to understand how to do it and use it and how to work with it. Our initial design frameworks, a lot of it's the one or the other. This is called like a linear process. You start with A, and then you go to B, and then you go to C. Or there's two forks in the road. You can go down one or you can go down the other. There's a linear path, and you can follow the path and you can do the outcome. For example, when we're doing a design and we're building a design system, when we create just the buttons we need or just the fundamental elements we need, and we add no flexibility and no adaptive elements to it and no ways to integrate different elements into it, we create a linear path. Because when you're looking through your buttons inside your design system, you can only use the buttons you have. You can only use the things that you built, and they are it. They do not change, they do not evolve, they do not adapt, they are the buttons. Full stop. A non-linear process would allow you the ability to have that button, but in that button is a wealth of options that you can tap into, adjust, change, and evolve. They can communicate new, different things because you understand the fundamental core points of what that element does. If it's a button, when you click it, it does a thing, but buttons do more than just being clicked on. They also have other interactions like hovering, as well as focusing, as well as checking on and off a particular thing. So you can have a lot more there under the hood, ready to go to enable through your design system. If you build it where you layered it and understood that it is going to need to adapt and respond to the ecosystem. And that's understanding all of the parts, just like in the world that we have it, we have an environment. And that environment is an ecosystem. They have different animals and different creatures and different things and different plants, and they all work together and they all do things and interact with things and have inputs and outputs. And that's what we take on board when we think of system thinking. It's a combination of linear and non-linear processes, and it's the interactions within an environment of space. And they're the things that we're thinking of as a designer as we are designing experiences that encompass more than just an individual. We encompass the world, or we encompass the landscape of the place that we're designing for, and then understanding the people that are in it, the points of interaction that are in it, and we understand they need to adapt and change. So we build design systems that do so. Well, how do we do that? We jump on to the first part of this, is where we have stocks and flows. Stocks and flows are the data as well as inputs that take place and are recorded and taken on board over time in our design system. And the flows, well, they're the sequence of events or the sequence of interactions or the sequence of expected interactions of our design system. When you see a checkbox, sequence of events and sequence of actions that can take place, you have expectations of what it does. So you start with preconceived notions. you clicked the checkbox, you then checked it on, and as you done so, it had done what you expected, and it followed through to being a checked item. So that is a flow of checking on an item. Very basic. There's more complex flows in this. And the stock there is that now I've checked that item on, and in this example of the 2 users using this to-do list, I need to communicate to both users that this item was checked. As we can see, we have 2 items that are checked here. We can see that potentially this orange user is the person that's using this checklist at the moment, or that you're the one that's on this checklist at the moment, just a mock-up. And you can see that there's a check-in for that one, and there was a check-in for the green user over here. We could make the assumption that the orange user checked this one on, and they checked that one off, and the green user checked off this one as well. And we could make the assumption where we are using this application, and because we're using the application potentially at the same time in real time, this is why adaptive design systems are important, and understanding the comings and goings of information and the use of information and the inputs that take place, we need to have a way to communicate to both users that the green user is actually editing this item. This was an item potentially made by the orange user, so the orange user is there and they can see it, and the green user is editing it. And whatever they're doing with it, we need to understand what actions and events that need to take place, and how do we communicate to 2 different users. We understand the input of interaction from the green user, and now we have to understand the output, or how are we going to tell the orange user that the green user is currently editing it. For example, we could use that Quark concept where we have a border control, so we have that design token that allows us to change that little design element that is our border. And we could use green, or a representation of something to do with this other user, and say, hey, at the moment this user is using it, and we use the border, in correspondence with the user icon. So we're communicating to the orange user that the green user is editing this check item. By doing so, we're using the elements of a design without changing the components of a design, and we are having the components of our design do the actions that need to take place. The actions might change between the users depending upon how it's being interacted with, so there's a lot of complexity here. But understanding the stocks and flows will give us the window into understanding the elements that we need to take in account for. And that's the point of understanding stocks and flows. The elements that you need to know about so you can design experiences that are more supportive and can help our users through the experience that we have put together. In addition, finally, there's other interesting factors that are at play here, because as we might be able to understand the stocks and flows, we can actually do an interactive map and understand all the pieces that could or could not happen in this circumstance. And one interesting one is where if we were having a shared application, we could have multiple users. How many users could we have? Because if we don't know how many users we could have, and we were to then take on this design decision of using this colored border on our actual element to illustrate the use of this element being edited by another user, then we might be setting ourselves up or an issue down the line where if we had 12 users on this application, do you want 12 colors? Do you want 100 colors? How do we support when you reach the maximum amount of colors that we want to provide? And how do we support the maximum amount of users we want to provide? How many users could fit onto one checklist item? And these are exactly the questions that will start to come from understanding the stocks, understanding the flows. You understand the pieces, you can start asking questions. You can start understanding the maximum and minimums of what you can do and how you can support it. From understanding all of that, we can get into our final piece of the model, where we can start to talk about the iceberg model. The iceberg model, like the Titanic, usually people can only see what's on the surface. And by the point when the event happens, it's already too late. And you've hit the iceberg and the ship sinks. Let's try not to just take on the events that just take place, and let's start to think a little deeper and understand the actual behaviors and the behaviors that take place over time. These are behavioral patterns that either are interactions that take place with your components that you have. For example, you can understand how a button can behave by the fact that you have used the buttons before and you understand the inputs and outputs of a button. Most buttons have clicking. Some buttons have an element where they can be selected, so they can be checked on or off in a way. And they can also not be clickable at all. So understanding the behaviors that take place with that item is helpful and helps you map out the elements to do with the stocks and flows. But not just understanding the elements is what we want to do here, but we want to understand the behaviors over time with the elements from our users. When we build, for example, the checklist application, let's say we're using it over time and the orange user's off to bed, and then a couple of items were added. How do they know that those items were added? How can they interact with those items that were added? Let's consider how we interact with a user. We can build up an understanding of the user and how they use the actual product over time, or use the components over time. We can start to see the patterns and behaviors that take place, and we can start to create the design changes to our elements that support particular behaviors and help make the actual application more understandable, more clear, more user-friendly. And that's where we go into behavioral patterns and understanding those interactions. As we dig deeper, the last part of understanding behavioral patterns is just understanding the mental models that are behind everything we do and use. From colors, where we in the Western world understand the red and what red means and how we react to red, and then understanding the mental models behind that, to the mental models behind green and other different colors. It's the same for fonts. It's the same for font hierarchy on a page. It is the same for the way that our UI elements work. It is the same for the sounds that we embed. It is the same for the animations that take place. It is the same for the tactile experiences that take place. Every element inside our design is all built of mental models. And with that, we can understand how to actually design elements in our design system that use mental models. Like a handle on a door, when you present it in a particular way, you could pull the handle or you could push the handle. The design of the handle matters because it communicates to the user through mental models. Like a toolbox with a bunch of tools, you know how the tools work to certain degrees. And with that, they communicate the function and the purpose of the tool. And our design systems need to do. Now, does that mean that we don't make anything new and we don't design new concepts? That is not true. But if we design something new, we know through mental models that we can use particular mental models to support it, to educate, or we will have to find other ways to support and educate when we come to designing elements that are new and different and behave in strange ways. So then we need to build a mental model. Knowing that is half the battle. And this is why understanding system thinking is really important. In the end, we are going to have the fundamental quark pieces, the tokens that have the core ways of communicating that adapt and change in our design system, allowing us to adapt and change the atomic elements of our design system that also have the ability to have interactions and can adapt and change, that then come together into molecules that serve purposes that can also adapt and change, that go into then the bigger matter elements that respond and change to the environment they're in, to finally the organisms in the complete system that we are designing, and that is the whole user experience that we are orchestrating. And those orchestrated user experiences are the environment that we as designers have designed that communicate through the elements inside our design environment, through the experience. So that is the theory, the advanced theory behind designing design systems and understanding system thinking and incorporating the atomic design framework, and then a little bit more. I hope that this has been helpful for you. Please let me know in the comment section below. But until next time, design thinkers, keep thinking and keep designing amazing things. I'll see you all in the next video.